trigonometric identities. So before getting into this trigonometric identities, or in short trig identities, let us review the basic trigonometric functions. We know that in a right triangle, here you have 90 degrees, so that's a right angled triangle, and in short right triangle. And let us identify its parts or the names of the sides with reference to this angle theta. So we have an angle here, and for that, with reference to that angle, of course, you have the hypotenuse, which is always the longest side in a right angle triangle, and it is opposite to this 90 degrees. Now this angle theta is formed by two sides. Out of those two sides, one side is already identified as the hypotenuse, so the other side has to be an adjacent side. So that's how you can label this right triangle easily. So this is the adjacent. Now you have an hypotenuse and you also have adjacent side, hence the remaining side is your opposite side, right? So these are the three sides of a right triangle. I started off with this angle theta, hypotenuse, adjacent side, and the opposite side. Now what are these trigonometric functions? The first known function, we know that it is the sine. In short, we write sin. Sine theta is equal to this opposite, I'll denote with the letter O, adjacent, let me call it as A, and the hypotenuse is H. So this sine theta is the opposite side over hypotenuse. That is, it is the ratio of the measures of those two sides. Whatever is the length of this opposite side, divide that length of the opposite side by the hypotenuse to get the ratio, this ratio sine theta, with reference to this angle. Now the second one we have cosine. Cosine theta is the adjacent side over hypotenuse. So I just have A over H. And the third one is the tangent. Tangent, in short, we write it as tan. Tan theta is equal to opposite side over adjacent side. So these are the three basic trigonometric ratios. Sine of an angle theta is O over H. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent side. So once you have those three trigonometric ratios like sine, cosine, and tangent, then we take their reciprocals, that is the multiplicative inverse. The multiplicative inverse or the reciprocal of this sine is cosecant. C-O-S-E-C-A-N-T, cosecant theta. In short, you can just say CSC. We write it as CSC, but read it as cosecant theta. That is the reciprocal of the sine. So we write H over O. That is the hypotenuse over opposite side. Similarly, the reciprocal of cosine is secant. It is a secant. In short, you write it as SEC. Secant theta is equal to the hypotenuse over adjacent side. And the third, the reciprocal of tangent is cotangent. Cotangent, and in short we write COT, cot or cotangent. Here tangent is opposite over adjacent, so the reciprocal is adjacent over opposite. So altogether we have 6 trigonometric ratios, that is sine, cosine, tangent, cosecant, secant and cotangent. If you have to remember them, I suggest you to remember it in this way. Sine first, sine theta, which is O over H, then cosine, you have tangent, after tangent cotangent, then secant, then cosecant. Those are the 6 trig ratios. So sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. Tangent, cotangent, those two go together. That is like this. Suppose if I have to write sine theta is equal to 1 over cosecant theta, and when you multiply those two, I can also say sine theta times cosecant theta is equal to 1. For example, if you have, let us say, sine theta is 3 over 5, then what is the value of cosecant? Cosecant theta's value will be 5 over 3, just the reciprocal of that. Similarly, cosine theta times secant is 1, and tangent times cotangent is also 1. Okay, then I have them here. Reciprocal identities are these. Sine theta is equal to 1 over cosecant theta, then cosine theta is 1 over secant, and tangent theta is 1 over cotangent. Alright, now what I'm going to do here is, let me divide this sine theta over by cosine theta. On division of these two, you know that sine is what? Opposite side over hypotenuse, and the cosine is adjacent side over hypotenuse. Alright, now we can see that it's a big fraction, and the numerator is a fraction and denominator is also fraction, and for those two fractions the denominator is common. So we have h as a common denominator, I mean same denominator we are seeing on both of them, so we can cancel them off, leaving behind opposite side over adjacent side. And by definition, you know that opposite side over adjacent side is nothing but what? It is tangent of an angle theta. So sine theta over cosine theta, that is on division of sine with cosine, that gives you a result which you call as quotient. That quotient is nothing but your third trig ratio, tangent. So sine over cosine is tangent. Similarly, if I reciprocate this, cosine over sine will be the reciprocal of tangent, which is cotangent. I have it here, let me show you. Yeah, quotient is it. So sine theta over cosine is a tangent, and cosine over sine, see the upside down, cosine over sine gives you cotangent of an angle theta. So these are the quotient identities. Now third, we have something called as Pythagorean identity. Okay, this is a unit circle. So on this unit circle, you know, the radius is 1 unit, and we have a point P here. The coordinates of P, let us say x comma y. Therefore I can say that the length of this side is x from the origin to this point, that measure is x, and this perpendicular or the y coordinate, that value is y. Alright, now Pythagorean theorem states that in any right triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. We know about it. We all remember a square plus b square is equal to c square. So in a given right triangle, the square on the hypotenuse is sum of the squares of the other two sides. So now here your a is what? Your a is x is x. So I'll write x square because a square. And your b is y. So I'll write y square. So x square plus y square is equal to c, that is 1. So 1 square. Now, what is this x and y? When I compare it with my trigonometric ratios, let me say cosine theta. The formula for cosine theta is c is a over h. So adjacent side is x over hypotenuse is 1. Therefore, when I multiply this, cross multiply 1 times cosine theta or solving for x, I can say my length of x, the measure of this x is nothing but cosine theta because of that radius 1. Otherwise, if this is something else, we even write that radius here, multiply it. But here I just have 1, so x equal to cosine theta. Instead of x square, now what can I write? Cosine square theta plus y. Similarly, this value of y is going to be how? Sine theta is equal to, for this angle, what is my opposite side? That is y. Y over 1, because I know that sine is opposite side over hypotenuse, and you know y is the opposite and the hypotenuse is 1. So that gives me y is equal to sine theta. Okay, so y square is going to be sine square theta is equal to 1 square, that is nothing but 1. So here please remember that this cosine theta square, when I say x square, we'll assume that it is cosine square theta, is the same as cosine square theta. That is cosine theta multiplied with cosine again will give us cosine square theta. You can write it this way or that. This is most convenient. That's why we write it as cosine square theta. And sine also, sine theta whole square is nothing but sine square theta. Hence, this is my first Pythagorean identity. Right? Very, very important. Cosine square theta plus sine square theta is equal to 1. Or sometimes they even write sine square theta plus cosine square theta 1. Either way, it is the same. Like suppose if you want to write it as sine square theta plus cosine square theta, that is again 1, the same thing. So what is the advantage of knowing this Pythagorean identity? For example, if you know the value of sine, let us say if they say sine theta is equal to 1/2, then what is cosine theta? You can just substitute 1/2 here, square it and solve it for cosine square theta and you will get the answer. I'll show you in the next examples in the next video, but here let us derive the other two identities also. Now next what I'm doing is, let me divide all the three of these by cosine square theta. Let me divide the first term by cosine square theta. The second is a cosine square theta I divided, and the third one also, this on the right hand side, divided by cosine square theta. So now what is cosine square theta over cosine square theta? Both of them are same, so I can cancel off, leaving behind 1. The ratio is 1 here. Now next is sine square theta over cosine square theta. From the quotient ratio, identities, we learned that sine theta over cosine theta is equal to what? It is a tangent, right? We'll use that, and I'll write here, because of the squares, I can even write tan square theta is equal to, so 1 plus tan square theta is equal to 1 over cosine square theta. Now 1 over cosine, we know that it is the secant. From where? From the reciprocal trig ratios. We have them here, right? That was a quotient I talked about just now, and then this one is, cosine is 1 over secant, right? So secant will be 1 over cosine. That's how these are the reciprocals. Let me go back there. Right. So secant and the square also I have secant square theta. So here it is 1 plus tan square theta is equal to secant square theta. Now to get the next one, third Pythagorean identity, I'll divide the same cosine square theta plus sine square theta equal to 1 by sine square theta. I am dividing. So on division of this, here cosine square over sine square theta is what? It is nothing but cotangent. Going back to the quotient ratio, we will find that it is cotangent. So cotangent, or in short cot square theta, plus this sine square I'll cancel off. Sine square and sine square gone one time, giving me 1 over sine. But what is the reciprocal of sine theta? Is nothing but cosecant, CSC, and there is a square, therefore I'll write cosecant square theta. That is 1 plus cotangent square, 1 plus cot square theta, or cot square theta plus 1 is equal to cosecant square theta, right? Those are the three Pythagorean identities we have. The first one is a sine square theta plus cosine square theta is equal to 1. Then 1 plus tan square theta is equal to secant square, and 1 plus cotangent square theta is equal to cosecant square theta. And the order of this, if it changes, that's fine. Suppose if you say tan square here, tan square theta plus 1 equal to secant square theta, that's fine. And even if this cotangent square theta plus 1 gives you cosecant square, it is just the same, right? So in the next video, I'll show you how to make use of these trigonometric identities to solve some problems. Okay, thank you. Thanks for watching.